The little record. Oh, there it goes. Okay. So I'm going to go ahead and present my screen. We have 4 questions for a warm-up, so I'm going to give you guys 7 or 8 minutes to work on it. I think that should be enough time. So I'm going to present my screen. And here's our warm-up. So number 1, simplify the following expressions. So you need to combine like terms, the ones that are similar that you can combine together. So make that one expression, so make it smaller. Number 2, use the charts. So there's a little graph on the right to figure out who brought in or how many students brought in 2 cans of food. So make sure you look at the how much each X represents. We haven't really done anything like this yet, so do your best on that one. We'll talk it through though. Number 3, you're going to solve for X, so solving that one-step equation. And number 4, this is kind of from the first quarter, find the prime factorization of 96. So it's 10:04. I'm going to give you until 10:10. That's 6 minutes. I think that should be a good enough amount of time. So go ahead and be working on that. Please. Please and thank you.
Miss Jones?
Yep.
Are we doing quizzes today?
No, not today. Maybe I think we have some later in the week, but we gotta do some review first to refresh our brains after a week, 2 weeks off.
Okay.
Okay. So go ahead and work on this warm up for now. Okay, a couple of you guys are finishing, so we'll do about 2 more minutes. Sorry, I'm just gonna check this really quick. Cool. Okay, yeah, we'll do about 2 more minutes. I'll let you guys finish that up, and then we'll review it really quick. Oh, I put that pencil up there. And we'll do about 30 more seconds, and then we will review it, okay? Alrighty. I'm gonna just look at attendance really quick. So if you're working on a problem, just go ahead and finish it up. I'm gonna make sure I got everybody. Okay, I think I've got everybody. All right, so I'm gonna stop presenting so that we can see the screen behind me. Good, so if you wanna pin me as the main one, that works. Can we see the board? We're all good? Yes, no? You see it?
Yes.
Cool, awesome, thank you. All right, so let's look at number 1. On this one, we combine like terms. Remember, you need to look for things that have a variable that's the same. So if we look at our first one, we look at the x's, we can combine together 3x plus 4x. Who remembers how to add together 3 and 4x? How do we do that? 3x plus 4x. What does that become? Any idea?
It makes it 7x.
Good, it makes it 7x. So you just take the 3 and the 4, add them together, and you get 7. And then you just drop down the x that's with it. So you get 7x. Good. And then our other parts are just numbers. We have 8 minus 5. So we're going to take our positive 8 and subtract 5. What is 8 minus 5? 8 minus 5? Anyone? Don't overthink it. We're just taking 8 minus 5.
3.
3. So when you combine like terms, you should get 7x when you combine 3 and 4x plus 3, because that's 8 minus 5. So 7x plus 3 is your final answer here. And you're done with that one. Okay. How'd you do on that one? Good, bad?
Good.
Good. All right. Number 2 here. We haven't really done anything like this yet, looking at a chart and figuring things out, but I think that this one you guys are capable of doing. It asks you how many students brought in 2 cans of food. So we need to look at the list of 2. How many X's do you see? How many were there?
Wait, I thought it was
That not what the question said? Look at it. It says, using the chart to the right, how many students brought in 2 cans of food to donate? So we need to look at the number 2. So we look at the 2, and we count how many X's there are. How many X's are there on 2? Can you guys see that far?
6.
3. Good.
Well,
So
yeah.
there are 3 X's, right? So we have 3X, but we know that X is 2 students. So X represents 2 students. So what is 3 times 2?
6.
6. So 6 students brought in 2 cans. Okay, so you need to take the number of X's and multiply it by 2. And you get 6 students that brought in cans of food. Okay, like I said, we haven't really done that one, so if you missed that one, it's okay. Hopefully it made sense when we talked about it. Let's look at number 3. This one we have done quite a few of. We have X plus 18 equals 47. So we need to solve for X to get it all by itself. If we have adding 18, how do I get rid of that? What's the opposite of adding 18?
Subtracting 18.
We need to subtract 18. If I subtract 18 on one side, do I have to on the other side?
Yes.
Yep, always subtract it on the other side as well. So these 2 will cancel out, and we're left with X equals, what is 47 minus 18?
29.
29. Good. So 29 is our answer there. And you can always check it if you don't know if you're right by plugging in whatever you got for the X. So this would be 29 plus 18 equals 47. And if you added that together, we would see that that is correct. So you can always check your answer if you need to. Okay. And then our last one, prime factorization. So we need to make that factor tree. So you get the numbers that are coming off the bottom to figure out what numbers multiply to 96. So what are 2 numbers that multiply to 96?
48 times 2.
48 and 2 works, so we'll have 48 times 2. And then we need to see if either of these are prime. Remember, prime means that only one.
2 is. 2
Good.
is prime.
1 times the number multiply in. So 2 is prime, so we can circle that. 48 is not. We know that 48 can be multiplied. A lot of things multiply into it. So what multiplies to 48?
12 and 4.
12 times 4 works. Good. So we have 12 and 4. Are these prime numbers?
No, you can keep going on them. You can
We can keep
simplify.
going. Let's start with 4. What numbers multiply to 4?
2 and 2. Those 2 are prime.
Good. 2 times 2. And just like up here, those are prime.
Yeah.
What about 12? What multiplies into 12?
6 and 2.
6 times 2. So we have 2 again and 6. All right. Can 6 be broken down more?
Yes, 3 and 2.
Good. 3 and 2. We know that 2 is prime because we circled it 4 times already. What about 3?
That's prime.
It is also prime. Good. Now, we're not completely done. There's one last step. Who remembers what we have to do with these numbers?
Don't you have to do the GCF and LCM?
We don't need to do the GCF and LCM. We don't. That's
Oh,
not really,
isn't it where you add them all up?
not add.
Add 'em, subtract them, and multiply them.
Multiply. Good. You take the numbers and multiply them. So it would be 3 times 1, 2, 3, 4, 5 times 2, 2, 1, 2, 3. A lot of 2's. So you just write them all out as multiplication. You can't even see all of them. There we go. All you have to do is write out this long multiplication sentence, and that's your answer. Your prime factorization is 3 times 2 times 2 times 2 times 2 times 2. That's your answer on that one. Nice and long. Okay. So that's our warm-up, just to get us back in the mindset of math, because we've been gone for a couple of weeks. I'm going to go sit down at my desk because my computer is going to die and I need to get it plugged in. But while I do so, I do believe we have an assignment that got posted on Google Classroom. So let's see. Under math, you should have some, okay, good. Graphing ordered pairs review. Do you guys have that? Can you see it?
I have it.
Okay, cool. Let's go ahead and get that open while I move over to my desk so that my computer doesn't die. Okay. All kinds of noises. Okay, there we go. Alrighty, so let's go ahead and make sure you guys have that open on your screen, please. I'm gonna start a GoGuardian thing so I can see it. I think it might have given, oh, well, no, you guys are each getting your own. That's good. Oh, well. Looks like Mrs. Mills is on here already because I think I put the wrong one online, but that's okay. You guys are all getting your own copy, but that means that Miss Mills might type on this before I get to, so you guys might see some answers early. Oh, well. It happens. So we have a bit of a review of how to graph ordered pairs and just the coordinate plane in general because we're going to use it a lot this quarter. We're going to plot points a lot. We're going to find distance between them. We're going to draw shapes and lots of things on a coordinate plane. So we just need to review it a little bit. Okay. So hopefully you guys have that open. We're going to go ahead and start by just reviewing parts of a coordinate plane. Okay. So coordinate plane is this nice chart, the graph with the lines. Up in the top right is quadrant 1. Remember, these go backwards. So quadrant 1 is the top right. Quadrant 2 is the top, oh wait, sorry. Yeah, top right. Quadrant 2 is the top left. Quadrant 3 goes down to the bottom left, and quadrant 4 is in the bottom right. So it goes counterclockwise. You start at the top, and then you go backwards around. When points are plotted up here, it's positive and positive. So if we plot the point 5, 5, it would be right in the center, right? Over 5, up 5. You gotta do your horizontal distance first, and then do your up and down, okay? If you plot something in quadrant 2, you're going in the negative direction on your number line, and then up, okay? Quadrant 3 means you're gonna go negative on your number line and then down. And then quadrant 4 means you're gonna go positive on your number line and then down. So we just got to keep those positive and negatives in mind. For this, what's it called? PowerPoint, you guys are able to drag and drop things and stuff. So we've kind of done this before, but they give you dots with letters in them, and it'll tell you move dot J to this spot. So you're going to be able to plot these points. It's going to be what I'm looking for when I am looking at this to make sure that you guys are plotting the points as we do it. You're going to do a couple on your own too, so just make sure that you are doing it, okay? It says right here that we can practice with this point on the bottom, so that means that we have to close out of our big thing. And you can click on it and move it wherever you need to. So it can be moved around. Once it's blue and highlighted, you look for those 4 arrows, move it around wherever you need to move it, okay? If you move it into the wrong spot, up here in the top left is the undo button. Just click undo. It'll go back to its original spot, and you can move it from there if you need to, okay? So yeah, maybe we are going to be Mrs. Mills. We're both going to be typing on this, and she's going to be like, what the heck? So, first thing that we're going to do, I'm going to zoom in. I'd like all of you guys to be on slide number 4. You guys are going to be moving around some points on your own here, so make sure you're doing this along with us. What we're going to do, zoom in just a little bit. 100 is good. We are going to determine the correct quadrant for the points below. So you have quadrant 1, 2, 3, 4, or none if it's on an axis. Now, if we look back at our thing here, the axis is the big line that has the numbers on it. So your x-axis is the horizontal one. The one that goes side to side is your x-axis. The one that goes up and down is your y-axis. So keep those in mind because you probably will use those. And we're going to drag these into the correct sections. We do not have to graph them yet. Just drag and drop. Okay? So let's look at part 1, or A. So I have it highlighted on my screen, point A. It says it's -5, -3. And we need to figure out where that even goes first. So I'm going to go back up here and look at this really quick. Remember, you always start at the middle of your quadrant. Right in the middle. Does anybody remember what that point is called? 0, 0? What is that called? Right in the middle.
Doesn't it start with an O?
It does start with an O.
Is it the origin or whatever it is?
Yep, it's the origin. It's called the origin because it's where you start. The origin is like your beginning point. So you start here in the middle, and our point was what? -5, -3. So -5 means that we are going to go sideways. We're going to do our horizontal distance first. We need to go -5. So we would go backwards 5. So 1,
Miss
2.
Jones,
Yep, 4.
this is all we're doing.
No, there's one more thing after this. If we have
Okay.
time. Yeah. So we go backwards 5, and then we have a -3. So if I'm going in a negative direction, am I going to move up or am I going to move down? What do you guys think?
Negative.
Yeah, if I'm going negative, am I going to move something down or am I going to move something up?
Down.
Down.
Down. Good. And we're going -3, so it'd be 1, 2, 3. Now, what quadrant did I just end up in? What does it say? Quadrant.
Quadrant 2 or 3? Wait. Well,
one?
is it all negatives or plus and a negative?
Yeah, we went -5, -3, so it's 2 negatives.
Oh, then yeah.
Quadrant 3. Good. So if we go back to our thing and we look at our point A, we're going to highlight it, look for our 4 arrows, and move that point into quadrant 3. Because we know that it was -5, -3. So it moves down to the 3. Okay.
I finished the thing right there.
Let's look at the next one though, because this one's a little bit tricky, right? Point B says 8, 0. We have a positive, but is 0 negative or positive?
It's neither of them. It's a number. It's not even a number.
Good, it's neither of them. So if we look at this and we're back at our quadrant, we start at 0, 0, right in the middle. It says we need to go +8. So if I go +8, I'm going to go to the right. Those are my positive. So I'm going to go to +8. And then it says 0. Do I go up or down at all if it's 0?
Well, it depends on the number. If it's like, so if the number is a negative number to the left, you go that way. If it's a number on that way, you go upward.
Good, you're right. So our first part was 8, right? So we went over 8 in the positive direction. And then we have 0, 8, 0. So if I'm moving 0 spots, am I going to go up or down at all?
No.
Nope. So I would plot my point right here on the axis, directly on the horizontal line. Am I in a quadrant at all?
Nope.
Nope, I'm in between. And there is a spot to put this point, right?
That's the none point.
Good, it goes in the none. So we would put it in the none. Okay. So I would like you guys on your own. I want you guys to try points C through J. You don't need to do all of them. Just do the top row, C through J. Okay. I'm going to give you about 5 minutes. I think in those 5 minutes, you guys can get through C through J. Okay.
Okay.
I
Alright.
did the whole thing.
Yeah, if you have time and you want to finish up the whole thing, go for it. I'm going to type in the chat what I want you to do. So go ahead and work on those while I write this, please. So just put the points C through J in the correct spots.
Which one is y-axis again?
The y-axis is your up and down one.
Okay, thanks.
Mm-hmm.
Why didn't they use horizontal or diagonal,
I don't know.
like or
Y
vertical?
or X first? I forgot.
They should have just did H and V. V stands for vertical and
Yeah,
H
that would
stands for
work.
horizontal.
Yeah. Charlie, when you're plotting these points, the first number in your parentheses is the horizontal, so you'll move left or right. And then the second number is your up and down.
Okay, thanks.
Uh-huh. Okay, we'll do about 2 more minutes. I'm going to check attendance again really quick.
I'm done with all of them.
Good. It'll take about 1 more minute, and then we'll just kind of review it really quick. And then I think that this is shared with all of the teachers, so I am going to have to put them back in the up on the thing. That's okay.
Are we gonna turn this assignment in after this?
We
And
will.
then that's the thing.
But we have one more thing that we're going to
Oh.
review after this too, just to get prepared for the rest of the week. We'll see how far we can get through the other one. But let's go ahead and review these. So point C, we have a +2 and a -7. What quadrant does that put this point in? Quadrant what? What do you guys
Quadrant
think? Which quadrant?
4.
Quadrant 4. Good. This one goes in quadrant 4 over here. Perfect. Okay. Because we went to the right 2 and then down 7. That puts you in quadrant 4. This next one, we have a +8 and a -4. What quadrant does that put it in for point D?
4.
Yep, that's 4 again. A lot of these are 4. Point E, you're going to go to the right 5 and down 8. What quadrant are you in?
The same one, 4.
The same one again, 4. Good. Point F, we have 0, 6. So we're going to move left or right 0. So we don't move at all. And then we go up 6. Am I in a quadrant?
No.
Nope.
Nope, we're right on the line. So that's your y-axis, and you're not in a quadrant. So that would be none. Okay. Point G is 6, 0. So we're starting at our origin in the middle. We're going to go to the right 6 and then up or down 0. So am I in a quadrant?
No.
6, 0. Nope,
No.
not this
It's
time.
the same as. It's pretty much the same as F.
Yep. So we are on the y or the x-axis this time. We're on the horizontal line. For point H, we have 4, 2. So we're going to go to the right 4, up 2. Am I in a quadrant? To the right 4, up 2.
Yes,
Yes.
you're in the first quadrant.
Good. We are in quadrant 1 on that one. Okay. Point I, we have -5, -5. So I went negative, negative. What quadrant does that put me in?
Quadrant 3.
Quadrant 3. Good. Oh, I'll put that in the wrong one. Awesome. And our last one that we're going to do, if you did the rest of them, awesome. But I'm only going to do A through J. This one is -1, 4. So we went backwards 1, so to the left 1, up 4. Where does that put us?
Quadrant 2.
Quadrant 2. Oops. Perfect. Good. So this is kind of what you should have. If you did the rest of them, great. Proud of you. Awesome. I think that if I leave this, the other teachers are going to see it because I think we're sharing this thing. So I'm going to do the undo until they're all back in the right spot. But you guys leave yours there. Okay. So I'm just going to move all mine back. Okay.
Miss
So
Jones,
hopefully
I thought the meeting was at 10 o'clock. 10:30. So what did I miss?
We're just working on graphing ordered pairs. So we're in that graphing coordinate points PowerPoint, and we're going to work on slide number 5. That's the one we're on.
Okay, I did slide number 4.
Perfect. Awesome. We're just reviewing. It's nothing new. We're just kind of reviewing before we get back into everything for this quarter. Okay.
Okay.
Cool. The last thing we're going to do, I think we'll do A through G. So we're not going to do everything, but we're going to drag our points to the correct place on here. So we're going to actually plot these points this time. So point A is -7, 3. So we start here in the middle at the origin, right? If I'm doing -7, am I going to move to the left or to the right 7? I'm going negative.
Oh wait, we put them on all of them? I thought we just sorted them into the boxes.
No, on this one, we're actually going to plot them in the correct spot. So if I have -7, am I going to go to the right or to the left? -7.
To the left.
So we're going to go to the left to -7, which is in between the -5 and 10. And then it's a +3. Am I going to go up 3 or down 3?
Up.
Up 3. So when we plot this, we're going to start here in the middle, right? At 0, 0. We're going to go backwards 7, up 3, and put that on the correct spot. So when you plot it, it should be at the -7, up 3. And do your best to get it as close as possible. Okay, so plot that point. And then we'll do one more together, and then I'm going to have you guys finish that. Not all of them, just the row, because all of them would be a lot. Okay. Point B says 5, 0. So we start at 0, 0. I'm just going to use my cursor on this one. 0, 0. It's a +5. So am I going to go to the left or the right? What do you guys think? Left or right?
Right.
Okay, we're going to go to the right 5. So over to the 5. And then I have 0. Am I going to go up or down at all? What do you guys think?
You stay just on the 5.
When on 5, 9, it overlaps 9 and 4.
That's okay. Okay, so that's kind of as close as I'm going to be able to get it. But for point B, we started at 0, 0, went over 5, and then there's no up or down, so it just stays there. Okay. I would like you guys to finish that C through G. So you have 1, 2, 3, 4, 5 of them to do on your own. Okay, so finish up C.
Can I turn it in now?
Yeah, once you finish C through G, you can turn it in. I will review them with you really quick, though. That's in the chat too, the ones you need to do. C through G. I'll give you guys about 3 minutes to work on that one, okay? Okay, about 1 more minute. Hopefully you guys are grasping the concept. Always go sideways first, and then you can do your up and down. We'll review these ones too, just in case, to make sure you guys went the right directions. I think the most common mistake I see is that you just flip which way you go first. So instead of going side to side first, you go up and down first. So make sure that you always go horizontal, side to side first, and then you do your up and down motion, okay? Okay. Let's go ahead and plot these ones. Let's start with point C. This one we have -3, -7. So we're going to go -3, which is backwards 3. So we're going to go 1, 2, 3. And then -7 means we're going to go down 7. So 1, 2, 3, 4, 5, 6, 7. And we'll plot our point there. Hopefully get it as close as possible. So that one is at -3, -7. You guys do good on that one on your own?
I turned it in because I got done.
That's good. That's fine. Okay. Our next one, point D, is 9, 4. So we start at 0, 0. You're going to go a +9 to the right. And then a +4 means you're going to go up 4. So that point is
Miss
about
Jones,
here. Yeah, what's up?
I'm done.
Good. Awesome. Okay. Our next one, point E, says 7, -8. So this one we start at 0, 0 like always. We're going to go a +7. And then we need to go -8. So we would go down 8. Oops. Move that. So 7. It's about here. +7, -8. Getting them as close as possible to the line. It's where the lines intersect, right? Not inside the squares, but it's where the lines cross, okay? Our next one, 5, 9, means that we are going to go a +5 to the right, up 9. It's a +9. So we're going to go over 5, up 9, and it's about there. Okay? And the last one we're going to do, G, is 8, -6. So we're going to go a +8 to the right, and then it's a -6. So down 6 is about there. So this is what you should have for A through G. Hopefully you have them in the right spots. How'd you guys do overall? Did you do okay?
I did good.
Miss Jones,
Yeah.
I
do
did
we
good
have
too.
to just do the first row?
Yeah, just A through G.
I
Okay.
did some extra.
If you did more, awesome. If you want to just finish it up and do all that practice, it's totally fine. You're more than welcome to.
Okay, do we turn it in?
Yep, when you finished it up, you can get it turned in. Just like last time, I'm going to undo all of these so that the other teachers don't have the answers already. And And then we have one other thing that we're going to do before we head out, so don't leave just yet.
Okay.
But you guys can get this turned in. There we go. Okay. And I'm going to close out of it. By now, you should hopefully have the other thing. Nope, I set it to go up tomorrow, not today. Let me just edit that and assign it to you guys.
Okay, I turned it in.
Awesome. Perfect. Okay, so now if you reload your Google Classroom, you should have something called absolute value review. So it's a little bit of review of some shapes, what absolute value is. We should finish it up by 11, and then you guys will have about an hour and a half until we have science. We move on to science now. Okay. So I'm going to go ahead and get this open. Give you guys a minute to get it open.
Are we gonna watch more Bill Nye?
We might later, but not yet. We talk about space now for the next 2 quarters.
I like space.
We should take a field trip to Mars.
That would be cool. I wish we could.
Yeah, but we'd be gone for 8 months.
Yeah. I don't know if I want to be gone for 8 months.
Have you seen the movie Rocket Man, that old one, where he goes up to space to Mars?
I don't think so, no.
Oh, it's funny.
No, I'll have to watch that.
It was
Alright.
on Disney Plus for a while, and then it got taken off or something.
It's not fun when they get taken off, huh?
Yeah, it's like they go through a thing of movies for about 3 months, and then they get rid of them and never bring them back.
I know, it's annoying.
That's how Netflix is too sometimes.
Mm-hmm. Okay, cool. I can see that a lot of you guys are getting onto that, the next assignment. Okay, I'll give you about 1 more minute to get there. And then it is just kind of a lot of review. We're going to talk about shapes because we do a lot of work with shapes this quarter, as well as plotting points. So I just wanted to review all of that. We're going to talk about some absolute value stuff this week, so we're going to review that. And then we'll kind of get into the new stuff tomorrow, okay? But we should be able to finish this up today. All right. I'm going to go ahead and present just because we don't need to type anything until a little bit later. So, like I said, we're going to talk about shapes right now, and just kind of review shapes and review what absolute value is. So we're going to start with shapes. We all know what a square is, I hope. It is 4 sides with straight lines. All of them are equal lengths, and they all create 90-degree angles. So a square should be a shape that has all 4 sides that are the same exact length, and they all have right angles on the inside. So this box right here is a right angle, and these lines mean that they're all the same size. Okay, so we have a square. Anybody have any questions about what a square is? Okay, cool. I didn't think we would. Okay. Our next one, rectangle, is very similar. The only difference is that some of the sides are a little bit longer. So a rectangle has 2 of the sides that are longer, and then the 2 sides are a little bit shorter. But the ones that are opposite from each other are the same length. So it's just like a flattened square a little bit. Any questions about rectangles? I don't think you'll have many questions on this part at all, but I just wanted to review it, okay? Our next one, equilateral triangle, means that all sides of your triangle are the same length. The angles on the inside are 60 degrees. We won't use angles very much. We're mostly going to use the side lengths and stuff. So, but later in life, it's good to know that the angles inside of an equilateral triangle are 60 degrees. But the major thing on a triangle that's equilateral means that all sides are the exact same length. Okay? Any questions on the equilateral triangle? Cool. All right. Next one is a right angle triangle. This one just means that, oops, too far, that in the corner, 2 of the sides create a right angle. So you have a right angle in one corner and then one long line that connects all of them. A right angle triangle. Questions about a right-angled triangle?
That and isn't there? Are we gonna talk about an obtuse triangle or like a isosceles triangle or what's the acute one?
We might, but I don't really think so. Not on this one.
Okay.
Miss Jones?
Yeah.
I don't think there's many questions because we learned this in kindergarten.
Yeah, I know, but we were going to use this, but we're going to put it on a coordinate plane, so it makes it a little bit more difficult than just seeing the shape. So we're just going to review it just to make sure that we're all on the same page about shapes.
Okay.
Okay. Our next one is a parallelogram. Have you guys heard of a parallelogram?
Yes.
Good. Parallelogram is basically, where's my picture? There it is. You take a rectangle and you slant it a little bit. That's really it. The two opposite sides, the top and the bottom, are going to be the same length, and the sides are the same length. It's just turned a little bit. Okay? And then our next one is a vertex or a vertice. This is where the lines cross, like the points on your shapes. So if we look at this pentagon, that's a 5-sided shape. There are 5 vertices. There's 1, 2, 3, 4, 5. So there's 5 points. If you think about a triangle, how many points would be on a triangle? How many vertices?
3.
3, because there are 3 spots where they meet, right? What about a rectangle? How many vertices would be on a rectangle?
4.
4. Good. So a vertex is just the points on your shapes. Okay? So we're just going to answer these. How many vertices are on this shape? You can just call out.
4.
5.
I got 2 answers there. How many vertices?
4.
4.
4. We have 1 in this corner, 2, 3, 4. 4 vertices on this one. What is this shape called? Which one is this?
A square.
A square
Square. Good.
Square.
Perfect.
pants.
Proud of you guys. Okay, our next one. How many vertices are on this one?
4.
4.
Good.
And it's a sponge.
So we have 1, 2, 3, 4 points. And then on this one, what is this shape called?
A sponge.
Spongy.
A rectangle. Good. Okay. Okay, so Dallin is saying sponge, right? I just thought about this. SpongeBob SquarePants is called Square Pants, but is he really a square?
No, he's a rectangle.
Yeah, he should be SpongeBob Rectangle Pants.
Yeah.
That doesn't even make sense though.
That doesn't make sense, but if you look at his shape, he is not a square.
Then
Okay.
I'm like, it
you made
doesn't
him look like
sound
a
right.
square.
That's what I'm saying. It
I don't
doesn't
know.
sound
Anyway,
right.
that was a bit of a sidetrack. Let's get back to our thing. This one, how many vertices are on this triangle?
3.
3. Oh, I just said what it's called. What is this called?
A
A
triangle.
pizza.
Pizza?
Specific type of triangle.
It's a isn't it a
Equilateral.
Good. It's an
Yeah.
equilateral triangle. All the sides on it are the exact same length. Good. Okay. What about this one? How many vertices?
3, and it's a right angle triangle.
Good. It's a right angle triangle because you have a right angle in the corner. All right.
Also known as a C-formed pizza.
What about this one? What's this called?
Parallelogram?
Yep.
Parallelogram. How many vertices are there?
4.
4.
4 again, right? We have 1, 2, 3, 4 corners.
2 obtuse angles and 2 acute angles.
Perfect. Okay. Now, we talked about this a little bit before, but we're going to kind of switch gears from the shapes just to review what absolute value is at all. Now, remember, the absolute value symbol is those 2 lines that are around the number. There's quite a few of you guys that confuse these lines with the number 1. So keep in mind that if you see these 2 lines around a number, it means absolute value. It doesn't mean 121. Okay? There's a lot of you guys that have done that. So I just want to make sure that you keep in mind that those straight lines mean absolute value.
121 does not equal 2.
It does not. So when we take the absolute value of a number, what happens to the number inside the absolute value sign? What happens to it?
You make it a positive.
Good, it just becomes positive.
But if it's a positive inside of that, then you make it a negative.
No, you don't. It stays positive.
No.
Yep, it's always positive. So, oops, too far. No matter what is inside your absolute value signs, it just goes to a positive number. If it's already positive, it stays positive. It's just the distance from 0. So if you have 0 on your number line, right, and you look at +2, the distance is 1, 2 jumps. If you look at -2, it's 1, 2 jumps. So it's always positive. Okay. So yeah, let's do a couple practice. This is one that we're going to type in. So I'm going to have everybody go ahead and make sure you go to slide 14. This is the last thing that we're going to do. We're going to do a few examples here. I'm going to zoom in. I think this is 100, but we're going to go ahead and get zoomed in on this. And we're just going to finish this out. You can click on it and type into it. Okay, I'll give you a second to make sure you're on the right slide. Slide
I did it.
number 14. Okay.
It's easier than I thought it was.
Slide number 14. Good. We got quite a few of you guys there. Perfect. All right, so on this one, we need to figure out what the absolute value of 5 is. What would the absolute value of 5 be?
5.
Good, it's a +5.
It's 5 away from 0.
Good, it's 5 away from 0, so it's a +5. Distance is always positive.
Yep.
Okay. So for that one, absolute value of 5 is 5.
5.
Let's look at our next one. We have the absolute value of -14. What does that become?
14.
14.
+14. It just becomes positive. Okay. So anything inside your absolute value signs becomes a positive number. This one we have
Oh.
2 of them with an addition in the middle. So we're going to do it separately. First, what's the absolute value of 2?
2
2. And then I'm going to keep my addition sign.
plus
And
8 equals 10.
Okay, the absolute value of -8 is a positive 8.
Could we just put like the 10 there?
Yeah, if you want to. But this number thing sentence that we're doing is kind of what we're doing this week. That's why I'm talking to you about it a little bit.
Okay, because
so
I just put 10 there.
that's fine. If you can do it in your head, that's totally fine. But just keep in mind that we're adding, right?
Yep.
And then our last one, we have, what's the absolute value of -3?
8.
Well, absolute value of -3 is
3.
Or
+3. Good. Let me do a couple of spaces.
plus +5 equals +8.
Good. The absolute value of 5 is a +5, and when you add 3 and 5, you get 8. Okay? So the only typing or anything that you need to do on this set of slides is on slide number 14. Just a couple of absolute value problems to practice. Once you have done that, you can get it turned in. That's all we're going to do for math today. So I'm going to stop the recording.